Okay, class, so we came to the last part of this problem, and it said if the Army wanted the margin of error of only zero point 0.1 centimeters, how many soldiers would they need to measure? Remember, we had a margin of error of 0.273 centimeters when we did this problem, and maybe they're thinking, no, we want a little bit more accurate than that. So they're saying they need a margin of error of 0.1 centimeter. So we want to know how many soldiers do we need to sample. Okay, so I just did this on a Word doc and the equation editor. If you look at our margin of error equation here, the margin of error equals our critical z-value times the population standard deviation divided by the square root of the sample size. Well, you can just solve this equation for n, right? So we bring that up here. Then we square both sides, blah, blah, blah. Anyways, we get this. So our sample size that we're going to need is our critical z-value, which is 1.96, times our population standard deviation, which is 1.92, divided by that margin of error that we're seeking, which is the 0.1. Okay, and then we got to square that. And you get about 1,417 soldiers, male soldiers, that they would need to, measure with all these measurements to get this margin of error of 0.1 centimeters, or, within 1 millimeter, let's say. So that would be pretty good. And so they got this mean. They know it's normal distribution. Then once they find that mean, they would know that 68% of their uniforms would fall within 1 standard deviation of that. We'll use a 68, 95, 99.7, so 95% of the uniforms or, shoulder widths would fall within 2 standard deviations, and etc. And by the way, if you go to that problem, you look at it, there's a place here you can actually look at the study, and they measured everything. I mean, they measured not only, for goggles, they measured, even on the helicopters or whatever they fly, and tank seats and stuff like that. I mean, they have to design those things based on these measurements. So this is actual real data that was taken, to determine this stuff. So I think that's pretty cool. It's pretty real world problem where you'd need a confidence interval, and you could actually use the z distribution. So there you go. That's the entire problem. Hope that helps.